button. I'm recording to the cloud. And as you've noticed, we have the closed captioning on and go. The participants are entering the room as I speak. I'm going to give people a few moments, maybe, 30 to 90 seconds as people come in. And then I'll just start with an introduction. And I've got a hand raised already. And I think we need to elevate someone to a panelist, which I think I just did. And we have, wow, lots of people coming in. All right, welcome everybody who's attending on this Thursday afternoon on Halloween. I'm Joel Christensen from Brandeis University, and with Elton Barker and some friends, we've had something of a working group going on Homer and AI. As you'll find out from a few of our presentations, AI is a pretty broad and general term for what we're doing. A part of the intention of this workshop is to share some ongoing work that's going on with Homer and computing, to set the table in a way for future conversations. So we'd love to hear some responses from people. We'll be monitoring the Q&A. If there's someone there who wants to jump in later, I can elevate you to panelists, but we'll also be recording this and sharing it for people to use as a textbook and inspiration of their own. I think that's probably enough for me. I want to start today. The first idea was to have someone come in and sort of set our baseline for our conversation, our understanding of some of the approaches. So John Pavlopoulos from Athens is going to join us and give us a basic primer on computing. And then we'll move on to some applications after some time for questions. John, it's over to you.
Thank you, Joel. It's a pleasure to be here and excited that already so many people joined. I don't want to scare you, but I mean, it's a warning that there will be code inside these slides. So it's a kind of a URL. It's a notebook. Here's a notebook. And this code has been translated into slides, so it looks good. But I think if we want to set the baseline, then maybe this is the way. So without any further delay, I'm John Pavlopoulos, and with Maria Konstantidou, who will speak right after, we have done some work on using language models, quite shallow, simple statistical language models, in order to approach Homeric language. And I will talk about the method we used in these publications, but in order to do so, I think it's a good idea to show how a language model works from the very basics, which remain the same as the large language models that we see today. So I should start with a very simple computation that takes place in computer science, and when we have to do with texts, and given two strings, two texts, edit distance is considered to be the minimum number of edits that we should do to go from one string to the other. So Levenstein distance, for example, uses simple insertions, deletions, and substitutions named after a Soviet mathematician, and it's well known so far. So I should jump directly to run this cell and see what I'm meaning. So its intention, then we have one deletion, then a change of one string, and from intention with these insertions and so on, we get the execution. So we move from from one string to the other. So if we take, for example, Homeric language or Homeric languages, then we should do 4 edits. We should remove 3, and we should remove one more S. So we could go from this to this, or add from this to this. And this is the distance. This is quite simple thing to do. This is in steps what I showed in that notebook before. So going from one string to the execution, just by changing one to the other. This is something simple, yet it's quite close to language models, as I'll discuss right next. So the statistical language models, at least, which are quite known for some time now, are based on the notion of n-grams. The n-grams are consecutive sequence. It's a contiguous sequence of items, consecutive characters or consecutive words, for example. It could be syllables or anything else. Here you could see from a verse of Iliad what a word n-gram, a word trigram, in fact, would look like. It's like a sliding window going over the words of the text, and the same could apply, of course, for characters, taking the first 3 characters, then the next, and so on. So we create a data set of sequences of items called grams, either characters or words or anything else. And then we could count, we could start measuring the frequencies of the items, how frequently each item occurs after a sequence of items. And then if we have these relative frequencies, I mean, how often a gram occurs after a sequence of items, then we can talk about probabilities. So having said that, I'm just adding a very small mathematical equation to say that if we know, for example, if we didn't have characters, we have the weather, and we knew, for example, that it rained yesterday, it rained today. So what's the likelihood that it will rain tomorrow? Then if we had a big data set of weather forecast in my area, and we knew that it always rains for 4 days, then it will be a very high probability that it will rain tomorrow. The same applies with characters. So if you have, for example, the counts of character A, B, and C, one after the other, and then we measure the counts of A, B alone. So by disregarding the 3rd character in the row, this is the probability of seeing C, the character C, following the sequence A, B. And this is the basis. This is the very basis that is used in language models. Either these language models are shallow or large or neural or anything else. I mean, you could use statistics to compute it, or you could use complex nonlinear functions, but still, this is the idea. So this is straightforward in Python. So maybe my idea was to bring in some code. And what I did here is I simply called a library, it's online, and there is the algorithm. So we can simply create a language model with this line. We create a language model that is character level language model, an n-gram language model. And then we are gonna train it on this very simple text. So I gave it a toy data set and simply trained it to learn the statistics, to learn the frequencies I just discussed. So let's see it in action. When we ask that model to generate character by character, it uses these statistics, the n-grams we just discussed. And it, for example, here, indeed, example, it worked, but then it's a word that it doesn't make much sense. And then it looks like an article, it's not. I mean, no, not even close. Then it looks like text, but it's not. Here again, example, and so on. But what we could do is we could really create a language model on a corpus of a more plausible list of sequences. So let's directly go to Homeric text. It's taken from a publication. Yeah, sorry.
No, sorry. I should have thought of this beforehand. Are you willing to take questions while you talk? Or would you prefer to wait?
Yeah, sure. Yeah, no.
Okay.
Questions right now, but I can't see the chat. So if you could interrupt me instead, that would be great.
Okay. So we have a hand up from Henrik Jensen. Henrik, would you like to ask your question? No.
Actually, it was a fall.
Oh, it was what?
It was a fall.
Okay. All right. Thank you. Sorry, John.
But it was an opportunity to say that I'm taking questions while we go. So opportunity will serve. So we have this text. So maybe I can jump back and forth in terms. I should also skip some slides with hardcore code. So for example, if I train this and then generate it, it gives different text. It starts from this as an example, and then it gives different text. So it's new every time. We're going to do it again because we said we're going to move over to Homeric text. So the first book of Iliad, for example, taken from a sentiment analysis publication. Each verse is annotated for how readers perceive the verse. I mean, positive sentiment, negative sentiment, neutral, or maybe the narrator speaking, so out of question. But here is, we're not going to use that. We're just going to use the text for now. And I'm going to give this text that we see, disregard completely any annotations of sentiment. And then I will let the model learn the verses, concatenate them, so disregard, not disregard, I use a new line so that I will let the model learn even how to produce new lines. And I create my new model exactly as I did it before, but now it's trained on the verses of the first book of Iliad. And let's see it live. I mean, I think I liked it at least when I did it. So you could see here that it generates text. It looks like, no, this is Latin. Sorry, I should train it again. So we have the model, Iliad, and we train it, and then we let it run. So now it writes quick. I mean, it's a translation from Kazantzakis and Kakridis, I think so. The language looks like from Crete, so it's not ancient Greek, but we can do the very same for the ancient text as I go below and say. So we can make it write really ancient text, or we could write even more. I mean, to me, it looks like ancient Greek, but also it's not. It's the style. So it's something that could confuse someone. It could be what people used to say, hallucination. So it's how a model would hallucinate and create something that looks like a style or maybe a language. Is there a question or no? Right?
It's me. Can I?
Yeah. So hi, Maria.
No, I was wondering, I mean, if we, give some rules for meter, then will it be possible to generate like correct metrical verses?
Well, I don't know if this will answer the question. I mean, you're talking about formulaic probably, or kind of controlling.
Like we have like the same hexameter in every verse, like not end up with a verse with one word. If we give it some rules.
Yeah, we could, definitely.
In theory, right?
I mean, I'm still talking about statistical language models, but I've tried it with neural, and I've tried it with large language models, which are, I mean, I don't know if I have this in, let's see.
Rule-based, like all the meter.
Oh yeah, this is ChatGPT. So I asked ChatGPT to replace the first verse, and it started writing. So I just prompted to change it. So it started giving a different, so it's controllable, of course, through prompting. Prompting was already known on the statistical path we were. For example, what we could do, it's different from what you said, yet related. We could take the positive verses from the data set, I mean, the ones that the annotators perceived as positive, and train the language model on the positive ones. I did it, I mean, just for the fun of it, and it really looked positive. So if we go to, yeah, this is it. I take the positive, and it creates something that looks, I mean, has luck inside, royal, and sweet talk, and so on. But if I do it on the negative, so it has some cursing inside, and kind of negative in a sense. So you can push it towards a direction, but you have no guarantee that the rules will be applied in the frequency that you want to see them. That's the trade-off there. No, please, thank you. I mean, disrupting me makes me feel more comfortable because I don't have to stick on the time, on the clock. I prefer that. So perhaps the style reminds of Homer already. This could be measured quantitatively, and this is the idea we had with Maria, starting with an MSc dissertation, then following up with a publication, then one after the other working on a method. But before I elaborate on the method, how do we evaluate a language model in general? So I should introduce a bit kind of the way we measure information. And it's the idea is that when you have something we have in a curtain and you reveal the curtain as if we were in a television, in a TV, you would say, how much information did you gain from this curtain falling? It's the same. We have a sequence of text, and then we reveal one more character. How much information did the model gain? And this is modeled with the logarithm of the probability of seeing that character given a history. And then we do this for all characters and compute the average. So in a nutshell, it's the average information conveyed for a character sequence, given the model and given an unseen text. So this average is our way to measure the linguistic surprise. How much did we gain? So the lower this value is, the more likely it is that the model has generated the sequence. If it has no surprise at all, then it's something that comes from its training corpus. So let's see this in an example. If I use this logarithm of a probability that is 0.8, so the logarithm, the negative logarithm of probability 0.8 would be something smaller than the logarithm of the probability 0.2. So it's reverse. So more frequent character sequences will achieve lower scores. That is the idea. And we can see this with a model we already have. If I change this phrase, tode mi ageo, to a different age, which like a direct language, so less frequent, it changes. It's more, ageo is more frequent, so it's lower. And then age is less frequent, so it's higher. And this is how we go from n-grams also to large language models. We predict word by word, character by character, or gram by gram. In fact, large language models have done lots of hacks down this path. So it's not like characters or words, it's in between, it's sub words or tokens. And they don't only have the objective of predicting the next word or the next character or the next gram and way the sub token. They also, they are tuned in human instructions. And what made them super powerful is that they are trained in billions of characters. So they predict, so they have seen the internet, they know the internet. But this is still the core objective of LLMs, and equipped with such objectives, they have the capacity we literally see today. So I should move now to the method. This is like warming up. It's the language models. It's how it works, nuts and bolts of a small or a statistical language model, also called n-gram language model. Same applies for large language models, but here is on the small. Yet we could have a statistical test with either language model trained on Homeric language. The idea is that we train a model on a book. So we take the first book of Iliad and we train a model. Then we take unseen parts of that book, kept out of that training material. And we compare the scores we get on those unseen texts with scores we get on texts from other books. This is a direct comparison. And what the test says that if we repeat this process for many sequences, comparing source versus target, and we have a consistent result most of the time, like 95% of the times, then it can't be due to luck. There is statistical significance in the unseen parts coming. So if it was like the Homeric hymn and we took text and it was indistinguishable by the large language by a language model trained on the first book of Iliad, then we could say that there is strong linguistic similarity because we only use characters here. Which, if we change the language model, then we could assess a different criterion. So source, text from Iliad or Odyssey, that kind of talking on the basics that Maria will follow up next. And we took as target text from Hesiod's Works and Days in Theogony. in lack of other contemporary literature. And the model indeed could identify most of the times which was which. So there was a notion of statistical significance in that. And I mean, it was quite confident in discriminating. So I'm saying thanks, but I also have a big appendix. I wanted to make a small stop in the case that there weren't any questions ahead of time, but I do have an appendix with 3 things I could say more, but I should make a small pause to see if there is anything I could elaborate more.
Thanks, John. Thank you for this quick primer and entry into it. I invite anybody who's in the audience to put their hand up or to write a question, and I'll channel it John's way, or anybody who's a panelist. John, I'll start it up by asking a simple question for those of us who are new to this. What are some common misconceptions that people who are new to this work bring to it? What's some misconceptions you'd like to disabuse people of right away about how the statistics works, or the data that's retrieved, or what's possible?
Well, I should start not with a misconception, but with a stereotype coming from the world of statistics that the data, if you torture them enough, they will confess anything. And that's something that used to work with statistics. Now it's a common concept in data science and so on. So we need to be very, very careful in how we perform and how we assess statistical methods like this one. And a common misconception, for example, is that if a large language model predicts or says something, then it's true. Or anyway, it's as true as a human fellow would say, or it's something that you could consider. But a misconception is that, as I said earlier, large language models have been trained in enormous amounts of text. And this means that you may ask something that has already been asked. And you're kind of convinced because it knows almost every answer. And then you ask something that it has not seen. And then you are misled to a hallucination. So hallucinations do exist, even though they don't show up. That's the first I would start. But I could give one more just to push the barrier. It's common. They call it self-explanation. So if you get like as I did with ChatGPT, I asked it to give me a verse. It said something, and if I say, "Explain to me why you used Trojan," so it changed, for example, instead of saying that Achilles brought sadness to the Greek, he brought sadness to the Trojans, and then the problem is that it produces an explanation that correlates strongly with humans. So humans perceive the self-explanation of the LLM as correct. But if we look under the hood of the LLM, it's lying in common words. So it does not believe the explanation it gives, but it's tuned to give plausible text to humans that could guide us into wrong explanations. That's my second favorite, especially because I have a paper on it, but I should stop.
Okay. Well, if you do have papers on it, we can drop it into the chat. But would you say that this sort of the ability of the model to lie to us is capitalizing on sort of our own cognitive biases, confirmation bias, etc.?
Well, the slides I showed invested on training. So we already saw the training procedure, taking a model, a simple model based only on statistics, simple counts. I mean, it's as shallow as it gets because a large language model has billions of parameters. The 70 billion, 7 billion that you may see on a large language model, it's how many weights it has. The more the weights, the more the capacity to learn, the more the data it has learned on. And I mean, I'm not sure how to put it. I may have lost you again. Can you please repeat the
Okay,
question?
no.
So again?
No, I was just talking about confirmation bias. And you don't. People want to hear from me. Let's get to a couple
Okay.
questions, and we may come around there. So I'm going to switch between the attendees and the panelists. So I'll start with Jasper Chen. What's your question, Jasper?
Hi, we might get to this later, but I was just wondering, how do you pre-process the text for input to the models? Do you use text that's already been cleaned, or do you do anything special yourself?
In fact, that was the result of an MSc student, Maria Fasoi, who did her dissertation. It all started from there. So she did a lot of editing and followed many assumptions, either rejecting symbols or accepting others. This was a workshop paper in fact, in Ukraine before the war, in Kiev, and it helped us move on. I would say that it's different in any book, probably. Depends on the editions, on how many interventions, on how many concepts, and it needs serious work. I wouldn't say that this could be automated. I can point, I will have the paper in the chat to see all the details on what has happened, but this is, this was lots of works, and the same applies to other joint works I've been. It's huge amount of time invested in pre-processing. So I wouldn't be able to do it myself. I would, as I did when I simply accepted everything and made the simplest assumption I could do.
Can I say something, because I was part of it on that, on the pre-processing? That, I mean, we decided to eliminate anything that was clearly editorial, like something that you know, a contemporary person would actually put in, or some editor. But I mean, for instance, we eliminated all punctuation. But we did keep all accents and breathings. It turned out that maybe we shouldn't have, because sometimes when you compare strings, identical verses are recognized by the computer as slightly different. So sometimes, I mean, it does need further actually cleaning up. Not too much, not substantial, but I think it's something that you end up doing manually.
Before we go on to the next questions, and I think we have 3 more at least before we change, could you, John and Maria, give us an idea of what the outcome is of not cleaning up the data? What are some of the sort of false positives or noisy results that you get if we don't do this pre-processing?
I think I already did, because what I did here in these slides, I took not pre-processed at all text. The ancient text you've seen here, well, yeah, this is not pre-processed at all. I simply scraped it from the internet and use it to train the model. So this has it all. This is my favorite assumption. I let the model learn everything, and then it can answer questions. For example, if we had a large language model trained on the full thing, then we could ask, is this symbol added by a specific editor? And what is the sequence? Is the sequence because Homer did it, or was an intervention? So you have it all included. It's not very fair. So if we had like statistical language models like this, maybe there would be bias inside if we're doing classification. Here, for example, I have an experiment from the work of Maria Fasoi, where we did a survey asking people whether they could read an expert and decide if it's Iliad or Odyssey. And I mean, experts did good, but the model, the language model, did equal good. It was on the top ranked anyway, as it was a top ranked expert. It could discriminate the two just by the linguistic style. And I should also add, I mean, it fits well your question that I just recalled, Joel. Sorry, I babbled a lot before. It's the confirmation bias. If a model lies about the decisions it took, why it took them, that's because it was trained to do so. So if you have like a human being and training him to say what others want to hear, he will or she will learn to do it. And then they will take decisions, but they will fool the others. So if we train it to do something, it will do it. That's the idea. So all the things we see are in the training. And I should raise two things, and then I'll give the ball to the audience again. First is biases existing in the data have gone into the model. This doesn't mean that the model is biased more than what we are. It's like the model picks up biases that we have and creates like an average using all the biases. So debiasing models is a huge thing because, I mean, can we debias a person? Is that an easy task to have that? Do we know how to do it? So it's like raising very strong questions we don't know how to answer. Yeah, sure. I'll stop.
Thank you, John. So some questions before we go on to the next presentation. Justin, and then we'll do Suzanne's question and Elton.
Great. Thank you. Thank you, John, for breaking this down for us. And it's good to see everybody here. I just have a point of clarification so I can make sure I understand what's being said, and then it leads to a question. So it sounds like these language models they're very good at detecting what is probable, what is plausible, what is likely. Is there a way to use this, the likelihood of something happening, to then kind of conversely flag or point out things that are outliers? Like, do these language models evaluate in any way things that are dissimilar or things that are outliers as possibly meaningful? And I think probably every Homerist in the room is, well, maybe not every, but I'm thinking about Iliad 10 in the various analyses that have come out. And so I'm thinking, it's like, well, yeah, maybe it is unlikely in some ways, but is it still meaningful even if it's an outlier? So yeah, I wonder what your thoughts or comments are on that, or if I'm understanding that correctly.
I had exactly the same question. So, I mean, I've tried to approach it with Maria through statistical language models so that I was sure, but before I come to this presentation today, to this talk, I asked ChatGPT. And ChatGPT responded like, the text I just gave you, the one that we saw here, this text, Κλαίθε αχιλίος δακρύων ποταμού, says it's not Homer. So definitely this is something like an intervention. So it predicted from the context its own text. So I said, no. I want what is considered as Homeric text, but is probably like intervention by an editor or by later poets. Can you find such? And then it responds, I wasn't aware of that, so I'm not a Homerist, but it said something about Dolonian, about the 10th. So this roundabout. So it says a lot of people says that this is not. So it could not do it, but it knew what people say. So this is the problem where the model has learned a lot in order to be controllable. And this is why statistical language models that are completely controllable could help us find something without being misguided by what has been written online and used by large language models. But Maria will tell more, of course, about outliers.
Yeah, we could talk about that in a bit, but it sounds like ChatGPT has gotten to the Oxford University Press catalog. So one from Suzanne, I'll read it aloud and then get to Elton. Suzanne, you still want to ask this question about how you direct the patterns that the AI trains on? Do you want to unmute and ask a question?
Yeah, sure.
Okay.
Yeah, I guess because you talked about the training period, how you train it, and it produced this gobbledygook, which and then you have to keep refining it. So I was wondering how you determine those training parameters such that gives you, the question or the prompter, something that you can make meaning out of. Because for it's all equal to the to the computer, right? It's all equal, like that string of letters, it doesn't matter, like that's meaningful to the computer in a way that's not meaningful to us. So like when you are building this and when you are thinking about training it to detect certain things, like how many how do you get it to prioritize what you want it to look at? Consider everything equal.
So I think this is where prompting stepped up. Before prompting, that paper that was quite simple idea, but yet it's one of the very most influential papers. And I could go on, but what was it? It was like learn to predict the next word by predicting the next token, then you kind of getting more meta information that was conveyed through these words. So the model started to hallucinate. T5, BERT, all the models could start generating text that looked like text, were coherent but didn't make sense. It was like dreamy, and this is why they were called hallucinations. But then it was the idea that let it do the same, but when it replies, have a person on the other side of the room and say, no, this is wrong. This is right. No, this is wrong. This is not plausible. I wouldn't believe it. So after training it on returning text that people would perceive as acceptable, it was further trained to give what you said. So now what we have is a strong language model that correctly predicts words one after the other, that what we humans perceive as plausible. But now we have another problem, that the model has learned how to fool us, how to give us plausible text, but not kind of believing its answers, or in a way, it's hard to bring excuses. So what we do is we try to unveil with prompting. If we want to do something, it's like you're an expert you're from the University of Oxford and you've studied like too many years and you know this and you know that. So it's like navigating to its memory, or if there are still debating on how LLMs really work. But if this is it, like it has encoded all the data in its parameters, then by prompting, it's like going through the parameters into its memory and letting it help us. We know that by this further training, it produces text that is helpful. I've heard stories how people alarmingly believe too much what LLMs say. So senior people, and they make conversations, long conversations. But still, I have another story where a doctor was writing the transcripts, and they were kind of messy because he was in a hurry. And apparently at some point he couldn't read his own letters, so he could not make it. But his cousin was a pharmacist, and she could read every word of it. So yeah, you're saying this, this, and this, and this. He remembered because she was trained in seeing. She could generalize. So I would say it's all about training, and there is the potential to reach a better network, and we'll probably see that in the future.
Could I ask a quick follow-up to that? With that,
Yeah.
So one of the criticisms of these models is that when they're scraping from the internet, they're actually having built-in bias in their basis, right? And so if the training also seems to be introducing some element of bias and prioritization. So how do you think about that? Like, is it, how does it not just promote the same things that, people have always, because even the trained researcher might reinforce certain aspects or others, or completely derail it, right? Like if that person who's giving the training prompts, if they're kind of an outlier within a field, how do you equalize to make sure it's more, generally meaningful rather than going off in a certain rabbit hole or direction?
I will start dropping in papers in the chat. So the one I just shared was an idea that started in Venice when I was a visiting scholar in Venice, and we were kind of annotating Homeric verses. And apparently there were verses that men and women perceived differently. The same verse, men were positive, said, no, this is positive, and women said, no, this is negative. And if we scale this up, it could be the same with people supporting Trojans and people supporting Greek. You could empathize. It depends on the context. So what we have is like a polarization. For the same thing, opinions deviate, but they don't deviate randomly. It's not noise. It's not variance. It's this or the other. I call this multimodality. Like you have one mode, one frequent value, that's the assumption we make today, and all models made that assumption that there is the average, the most frequent value, and they learn to predict that. And this is how bias is injected in the models. But what happens when you have like one opinion from people that are in one side and then another from the other side? Take religion, take political beliefs, take age, take gender, take whatever. But then there is a problem. My future research plans to go that way because I found a measure that could capture these items. And then what I'm planning to do, so it's not done, but what I'm planning to do is find a machine learning way, a way for the machines to learn, to respond like this part is positive to him, negative to her, neutral to these people, so it could learn to give multiple signals. This is not done. This is far from being implemented. We need more new algorithms to make that happen. But I mean, hopefully that will be my future step.
Thank you for that, John. And Suzanne, thank you for the question. We have talked about similar issues like this, Elton, Maria, John, and I in some of our meetings. And we're interested in the potential for these models to find patterns we haven't seen in different speakers by gender, by background, et cetera. Elton had his hand up, but I'm going to pull rank on him just for this one and move us on because he gets to talk in the next session as well, where Maria, Konstantidou, John Pavlopoulos, and Elton will talk about some of the research they've done that I shared and posted about before that can help us sort of move this conversation to some specifics. So John, Maria, Elton, I don't know who's driving this one, but I look forward to hearing what you have to share today. Maria, if it's you, you're muted still.
Okay, cool. Okay, now, right?
Yep.
So Elton, now you can talk as much as you want. This is our presentation. Let me figure out where I am. Okay. Okay, so I mean, the whole discussion moved a lot towards generative models, so how they produce speech. Luckily, we don't have such concerns in the work we've been doing so far, because we haven't been using the models to generate text, but we just compute the probabilities of the existing text. And as Justin actually pointed out, our work has been focusing mainly on spotting outliers. So what we do, I mean, our general methodology, these are the publications so far that we've had with John and Elton and Chiara and Ryan, who will be speaking later. That our general methodology, already described by John, is that we train a statistical character model on a unit, and then we use this model to score how well the target unit, a book or a verse or a passage, fits to the training unit. So if we train on the Iliad and then we score one of the books of the Odyssey, we want to see how well this book fits in the Iliad, with the Iliad language. I mean, this is kind of layperson explanation. The truth is we just predict how surprising it is to see the new text. But roughly, it corresponds to this. If it is close linguistically, it will surprise the model less. So that's the idea. And I mean, we've gone on several levels. First, book level evaluation, that was our first work. We were trying to figure out how surprising each book is to the global model of that book. Example, we train on the Iliad and we want to score to see how surprising the first book of the Iliad is to the rest of the text. So we use the whole Iliad for training except book one. And then with this model, we calculate the probabilities for every single trigram, and we average it roughly for every single we use trigrams in this one, trigram of the first book. And then we do the same for the second book. We train another model with all the books except the second, and then the same, third, fourth, etc. And we end up with 24 models per poem, and we average it. And I won't bore you too much, but this is our initial results. So for the Iliad, it seems that the most surprising books to the whole, like Iliad, the ones that fit less as a whole, though, as a book, to the rest of the Iliad is book 4, 9, 15, 16, and 21. For the Odyssey, that's 9, 12, 6, and 7. We also did a correlation between individual books. So what we did, we trained on one book, book 1. And then we used this new model on book 1 to score book 2, book 3, book 4 through to book 24. And we did this with book 2, train the model and then score book 3, 4, 5 through to 24. And the heat map shows here the correlation between each book. In the Iliad, I mean, there's still some correlation that we can spot, like red is a positive correlation, so it means they're close. Blue is a negative correlation. It means they're distant from each other. So basically books 11 to 17 seem to have some affinity, and books 1 and 24 seems to be distant from several other books. But the Odyssey produced a much clearer pattern, and that's books 9, 10, 12 seem to be negatively correlated to most other books, except among them. So book 10 has a positive correlation with 9, has a positive correlation with 12, and a positive and quasi-positive correlation with 11. So that was actually, it's such a clear pattern. We were startled when we saw it, and we think it's an interesting result. We discussed quite a bit about it with Elton later, who was able to give some insights in it. So Elton, feel free. And that was the book level. Then we decided that, I mean, it's fine, book 4 stands out, but book 4 is like a long book. And there's, I mean, you know better than I do that they're not uniform, and there are like certain sections in each books and passages that are contested, and some others that we feel fit better. So we decided to take it on a passage level and trying to find out the ones that have bad scores, that's high perplexity scores. I will be using the term. So high perplexity means it perplexes the model, so it's not very close. So we trained on the whole poem, excluding each time the targeted passage. The passages are 600 character long, that's roughly 12 verses. So we trained one model for every 6 character passages. It means we trained on the whole poem, except, and from which we excluded the 600 characters, and then we scored them. And this is all the 600 character length long passages that we scored. And the ones above the red line are above the 95 percentile of the other scores. So the really, really outliers. But we also take into account the ones that are less of an outlier. And what we were looking for is not a single passage that scores really, really high, because it doesn't say a lot. What we were looking for was clusters of such passages that indicate that the whole like passage somehow stands out. And we did this for the Iliad, we did for the Odyssey. This that is really, really striking, and this is the best we found in the Odyssey. But this was the first one from the Iliad, was from book 2, as you probably expected. It's the, no, you didn't actually, you thought it was book 10, didn't you? But it was, it was actually from book 2. And I mean, for those of you, most of you who know well, the Iliad, you realize it just after the middle of the book, so it's the catalogue of ships. And in the Odyssey, it's actually the catalogue, part of the catalogue of women. And I mean, if you want to delve more into it, it's in our paper, but just for the sake of it, I highlight here the most surprising passages to our model from the catalog of ships. So these are the ones that were flagged by the model. I'll give you a moment there. And then our next step was we went at the verse level. So now we in this work with Ryan and Chiara, we created a resource which is available online. This
Maria, do you mind pausing for a question? I think we've got a hand
No,
raised if you
no,
don't mind stopping. So we have, and Anthony Robb has a question that he just put his hand up for. Hi, Anthony.
Yeah, Maria, I noticed that book 1 and book 24 were very similar in the model. And I was wondering if that's, well, because the story has to have a plot and book 24 kind of mirrors book 1, would it then require that it has similar language and then show up in the model as such? What do you think about that?
But actually, maybe John even has a better insight. But if I'm wrong, correct me, John. Because we're working with at the character level, and because we're using trigrams, which are pretty small n-grams, I think language is more taken into account than content. Am I right, John?
I think so.
Yeah, they're not so sensitive to the content as to the language. Of course, you know, they're not like independent from each other. So possibly yes. And the same, I guess, goes for like the Odyssey 9, 10, and 12. Elton, it's your presentation. You don't have to.
Well, I think I still have to stick my hand up. I feel as though I'm very much the outlier here too. I just noted Justin's comment in the chat about the catalogs, and I think so I first saw John and Maria present this in a conference about a year ago in Patras in September of 2023, and apart from reminding me with some terror about my A-level maths and stats, and I used to hate A-level. I was much more of a pure maths person. I hated the stats. I was really struck by a few things and really excited, as well as being perplexed, of course. So I think this might be the appropriate time just to have my initial reaction before we go on, Maria, just in terms of, because I think this is what we're looking at here is quite useful, as well as that previous book diagram that you showed. So a couple of things that really kind of stood out for me in terms of this model. First of all, that very clear sense in the Odyssey that 9 to 12 are different. Now, of course, they're different. We know they're different as human readers of the Odyssey because this is first person narrative. So there's going to be, this is a different mode of narrative, and it's something that Justin notes in the chat too about how that's one reason why book 2 of the Iliad stands out too. So what I liked about this was this is confirming something that we kind of know, that 9 to 12 are different. Book 2 with the catalogue shipped is different. I think it's quite useful in the digital humanities more generally, when you're using these digital tools, when you're looking for patterns, because a lot of it is pattern based. We kind of like to have patterns and try to solve puzzles. That initially you get that. I mean, you can call it confirmation bias if you want to, but a confirmation of what you know is really quite useful. So it gives you a sense that maybe there's something here in the model that's worth thinking about a little bit harder. And by the same token, what's not an outlier, or the two books that aren't outliers, are Iliad 10 and Odyssey 24. So that was again very striking because with my preconceptions, assumptions, I would have expected Iliad 10 to stand out. I would have expected Odyssey 24 to stand out. And in this model, they don't. So that in addition to the confirmation of, oh yeah, of course, the catalogue poetry is going to come out in a different way, the fact that Iliad 10, Odyssey 24 don't is also interesting and gets you to think, It got me thinking a little bit harder about expectations of what we might want to look for in those books, or more generally across the two epics. I might say some words after, a bit later, Maria, but I thought that it's just useful to get to say a little bit about my initial reaction to your presentation before.
Yeah. John?
Maria, I think you should start, because I'm having the kids near and I'm missing like half everything. You can hear them screaming. So this is why I'm close my camera also. So I have technical issues, I would say.
Okay, so this, I mean, if this link or the QR code leads to John's GitHub page, and this resource, the home, as we call it, is published, and this includes 2 Excel files with all the verses of both poems, and they are scored with the PPL score, perplexity score, that shows how surprising they are to each model. There's an explanation of what each metric does. But I mean, I will try to cut it short and just say that we came up with other metrics, a metric that shows how surprising each verse is to its own book. So we trained in the whole book, except the one verse, and then we scored the verse, and we did that for, I don't know, 600 times, if there's 600 verses. And then the cross score, which this is quite fun. We scored with an Iliad model, and we scored with the Odyssey model. And surprisingly, some verses fit better to the Odyssey than they fit to the Iliad. And this is what we call the cross score. The findings very quickly are that this is also interesting, because to me at least, of course, if we have rare words, and rare like 5 grams, now we've moved to 5 grams, of course it affects the perplexity score of the verse. What was surprising to me at least was that if we remove all personal names, it doesn't really affect the perplexity score. So to me, at least, it was surprising. I thought it was a huge bias that we introduced when we gave a verse with a name, especially the person's name. Yes, John.
Not sure if it affects the perplexity, but it doesn't affect the relationships between. So it doesn't change the results. So it might affect the perplexity, but
Yes.
definitely not the results, which was surprising.
Yeah. Yes, it was. It really was. We've talked about it for so long, the two of us, and then Chiara and Ryan came on, and they also were concerned about this, and then we tested it, and that was surprising.
And maybe I think maybe Ryan could step up, but I really think he has an app that is very cool, using the Excels on top of them, but leaving that to Ryan.
Yeah, that's it.
Yeah,
Yeah,
right. Sorry,
that
that's
link there is
cool.
yeah, the nice app.
And the QR code leads to that link, and it's actually user-friendly GUI that, unless you have like super complex searches to perform, you can use this app. It's much more user-friendly than the actual Excel files. So very quickly, we use the cross score, the one that shows whether it's closer to the Iliad or the Odyssey. I mean, as you can imagine, most, like the vast majority of the verses are closer to their own book, but there were some, and this graph shows which books have the most positive cross verses, as we call them, the ones that are closer to the other book than their own. And wait, that would be for actually the ones with the most verses is Iliad 9 and 24, and then 1, and the one with the least verses is the Odyssey 23. There's also the comparison between locally surprising and globally surprising, the ones that are surprising only to their own book. I mean, some books fit better in the Iliad than they fit in their own book, and that's also interesting. That's the ones that stand out. So what we found out about especially the inter and intrapoem unexpectedness, that cross-poem elements like proper names, but also thematic overlapping and narrative elements affect these scores. Examples like when we see Odysseus in the Iliad and Achilles in the Odyssey. Books of interest, as we pointed out earlier, and Elton spotted that patterns that are recurring in picked out passages are basically lists and similes and narrations from the past. And that's it in a nutshell. The key takeaways is that the statistical models that we are using, which are very, very simple, and there's no black box as in the neural models that you don't know what's going on, it's pure statistics. They can actually recognize texts from Homer and Hesiod and also Homeric hymns, and they can tell between the Iliad and the Odyssey most of the times. And the models have highlighted, as Elton pointed out, the passages that scholars have been talking about for a long, long time, although it did not flag Iliad 10 and Odyssey 24. Some features seem to be more perplexing to the models, like the similes and the catalogs. And mainly, all these experiments, we have a lot of data, and we need experts to look at them, like Homerists, and start making out patterns and understanding what, if any of it makes sense, and actually help us develop further experiments, which is why and how we started working both with Chiara and with Elton and Joel. So what next? As we mentioned, the data pre-processing, we need to correct a few things, although it won't substantially change anything. It's just, sometimes it kind of messes the results. Not too much, so it's really minimal. And test the formula, see how we can work with formulas, the Levenstein distance that John showed earlier. We can spot, except apart from identical verses, we can also spot partly identical verses. And we are in the process of doing this. We can investigate whether traces of other traditions can be identified. We can actually employ more advanced models, which are not nevertheless as clear in the human mind how they work. Maybe we can expand it to generative models like we've been talking about, and any ideas are very welcome and hugely appreciated. And Elton.
Well, I don't really have much to add. I kind of had my intervention before, but I did have some questions. One of them is just for clarity, Maria, because I was going on about how Iliad 10 doesn't stand out. And then in one of the later visualizations, it does stand out a little. So can you just explain what we're showing there? Why Iliad 10 is... That's when we're doing the measure against the Odyssey, is that correct?
Yes. Oh, yes. Yeah.
So this.
No. This one is local versus global perplexity. That is, the red ones, the red bars, show the verses that are surprising to their own book, and actually they have more verses surprising to their own book than they have verses surprising to the rest of the Iliad. So they don't fit well in book 10. That's 12. Sorry. Example. They don't fit well in the book 12, but they fit all right in the Iliad in general. So we have such cases. And 10, actually, it's pretty average here.
So Elton and Maria, we have a question from Anna Conser, and then I think we're going to shift to Stephen Sansom's response and some questions that he'll shepherd. Anna?
Yeah, can you hear me?
I can hear you.
Great. I just wanted to ask about kind of what these models are measuring in a way, particularly the difference between style and content. And it seems like most of what these models, as I understand it, they're trained on just character sequences. that it would be dominated by the vocabulary, just kind of like what I think of as the content rather than how it is arranged. And I think that's part of what's happening. It doesn't make it less interesting, but I was curious whether you've experimented with ways to control for that, such that you could, you know, not just blocking out proper names, but thinking about different lemmas and trying to look at something other than just whether the same lemmas are appearing, whether there'd be a way to control for that. I was just curious if you'd tried anything along those lines.
I think this goes to me, Maria, or you want to
Yes, I think yes, you or even Ryan. But if you're available, because I thought you had the kids around.
Yeah, I have some technical difficulties, but I can try. I mean, I have very good noise cancelling, so good for you. The idea is that we don't want to go to content, so we don't want to go to words. Also, many biases go into there. So we picked characters for many different reasons. If we start working with lemmas and tokenized and words and so on, we tried that, in fact, in some experiments, some similar questions. I think Ryan and Chiara had similar concerns. But then why stop there and not go into large language models trying to do that and encode really, really complex neural? Why go into rules and not encode everything? Not sure if this is future direction or if this encode it all inside would lose control in a sense. Not sure if I'm answering.
Ryan, did you
I
want
thought
to
I might just jump in and add something there, which maybe to expand a little bit on one of the results from our joint paper, which is that we found there was a very strong correlation between the token frequency of lexical items and the perplexity of verses. So that indicates, so Anna, your question is an excellent question. And I think this is actually indeed a sort of problem if what we want to try to get at is what is really linguistically distinct. If we're using something that's very superficial, you know, we can't directly interrogate the grammars of ancient Greek poets in this sense. And in that sense, that's what we'd like to have. But we have these superficial sequences of what were originally sounds now put into characters. But we see that what actually happens is that the presence of low-frequency lexical items drives up the perplexity of a verse greatly. And so if it happens to be the case that there's some content word, some word that happens to be used very rarely but only occurs in one verse, then that verse is going to have a very high perplexity. And I don't yet know that we've entirely worked out a way of trying to get around that. I know when we were working on the paper, we were discussing some ways of trying to adjust for this sort of bias, to adjust the perplexity scores in some way to take account of these factors that seem to, from our perspective, perhaps artificially drive up the perplexity scores and take us away from what we actually want to get a measure of. But I think we hadn't entirely worked out a fully satisfactory way of doing that.
We did have
We had some ideas.
I think we did in the home resource. There is a metric, the IVF, if you remember.
Right. Yeah, the IVF metric, right.
Yeah.
No, we did some experiments in that direction, but there are more. I mean, if you go into words, if you start working in that direction, you have multiple problems that do not appear. For example, if you work on characters, you have few terms, few tokens, because characters are limited. When you go to vocabulary and content, you have unlimited. I mean, it's
limited.
It doesn't make, so you have multiple problems open. It's like opening weaknesses all over. So we can control it in characters. If we go into terms, I think it's very difficult to keep it controlled. We did, though, some experiments, especially the IVF. I think is a very interesting index, and it was, I think, yours or Chiara's suggestion, Ryan. But the question is to the heart of that debate and criticism we already.
Thank you, guys. And I think this discussion is getting right into the heart of some of the problems with using this for interpretation. And so as a way of getting us into more conversations and thinking broadly, I'm going to invite Stephen Sansom from FSU right now to come in, and we'll highlight him once he turns, where is he at? Sorry, I'll add him to the spotlight and let him provide his response right now.
Great, thanks so much, Joel, and thank you all for your paper. It's great to be here with so many familiar faces and new faces too. So I want to start off just with a little bit description of where I'm coming from to this workshop today, and then I'll have some particular questions to get the Q&A started. Sounds good? So first off, I must confess something. So I'm a proud Homeric bean counter. You might have heard this phrase before, counting beans. Give me a list of formulas that preserve the digamma, or better yet, formulas that don't preserve it. What are the books and line numbers for each one of these things? Where are all the breaks in Hermann's bridge, or Varro's, or Meyer's first, second, or third law? What's the metrical position of every word, lemma, metrical shape, tone shape, in every Greek epic from Homer to Ioannis Tzetzes? I want to know. And I co-developed software to find out, but why? Why do I count beans? I can think of 3 reasons, the last of which pertains especially to AI in our conversation as we've been having today. The first reason why is style. So this goes back to Anna's question somewhat just now. Linguistic and metrical features tell us something about who characters are, what they're like, what narrators are like, or authors, or eras. Just as stylometricians have been doing forever, whether with computers or punch cards stolen from accountants, I count to make new connections and discover new webs of style. But I also think that counting helps us get at what epic poetry may have felt like. And Maria, I think you might have mentioned something this a moment ago. Like what words may have irked an audience's attention because of an unusual place it might have occurred in the line, or next to a certain kind of word or a metrical position. But what passages seemed sweeter because they have a more familiar rhythm? Or what phrase may have triggered linguistic surprise, as we've been talking about today? John mentioned that, Maria, as well. So I count that I might better qualify aesthetics and quantify aesthetics and read old passages in new ways. But the third reason I count is because I'm most convinced by arguments with good numbers. Maybe this is like the philologist in me. Intertexts with a heap of features unique to 2 passages. Formulaic constructions whose proliferation challenge their prehistory. So like computational linguists, I like statistical claims that show their work. So this type of evidence, I think, is both an opportunity and a challenge for AI. Now these models are helping us build computer code, and that helps us populate our CSV files and all of this within reason, but it can do a lot of things quickly. But I often find myself, which I think our chat has as well today, as in like literally the chat. Why does the model predict what it does or generate a text that it does and shows us? Like, what are the vectors that led it there? Where are the proofs? How did we get to this hill of beans that I can count? So that's where I'm coming at, more from the statistical nuts and bolts. Like, I've not used large language models in any of my work. But some questions that I have to get us kicked off today are a few things that stood out to me in the presentation just now. The first is the idea of perplexity in this PPL score. I was wondering if you could just talk about what constitutes perplexity in this way, either just mathematically, computationally, or if it gets into the psychological, if anyone has ventured there. So perplexity is my first question. Second follows up on tokens. I'm wondering what tokens, if it's character by character, like what tokens are first person tokens that show us Odyssey 9 through 12? And we're like, oh yeah, there's a lot of these first person tokens, whether that's character or like clusters of characters, whatever that might be. So perplexity, tokens. And then the second, I really liked the method that you shared of identifying words to take out of the model and see what happens next, if that changes the score. I would love to know more about that methodology. I'd love to know more about that method. So thanks. So yeah, perplexity, tokens, and taking out words.
John?
So I can help there. I don't know who wants to start, Maria or John.
I want
But,
not to
okay.
start now due to some noise issues, but if you Maria could start, I could follow with perplexity.
Okay, should I don't know, you already explained that. I mean, should I just try to share once more my screen? Wait, give me a minute, sorry. To make it a bit more wait, I cannot wait. Sorry. Oh, that is okay. Because I wanted to show something which is here.
But that's I'm having some quiet moments here. When you say, Stephen, first person tokens, I'm not sure I understand. Could you elaborate?
Yeah, so this is going back to actually something Elton mentioned. So explaining why we see the difference between Odyssey 9 through 12, why they are cold colors versus warm colors in the heat map showed earlier. Elton mentioned that this is not surprising in so much first person in these the Apologoi. So I was wondering if that notion, which is very much, that's what I was like, I love seeing that chart for that very reason. I was wondering how that might map onto the tokens that are included in the way the model is trained. If it's like there are a lot of omegas, for example, in books 9 through 12, and omegas are more often associated with the first person, like verbs or whatever. So that's what I mean.
Okay, so just to clarify something, it's not about unigrams, so we don't use single characters. So it's never about omegas. The priors are kind of disregarded, and this is also important because we have a few characters. It's how many times an omega appeared after a specific sequence of characters. So even if omegas are dominating, it doesn't make any sense. You can change the sequence and reboot everything.
No, but if you have like men, if you have the men suffix and you keep, bumping into it, then you get a lot of first person trigrams, and I mean, I've made these usually
first person trigrams, yeah, but not first person. I mean, unigram, not character. So it's a character that dominates. That this is something we know. But if there is like a token that dominates a specific chapter, then it's dominating also the research. It's like a specific word should appear. But we didn't get anything like that when we searched, I think, Maria.
Stephen, it's a very good question. I mean, obviously, my eyes were instantly drawn to 9 to 12 because they're first person. Why there's that perplexity for those books, however, might not depend on the fact that it's first person, I suppose, is one way of thinking about that. So I guess it's that the model, we need to dig more into the model to discover why perplexity is being shown there. I mean, it maps up quite nicely onto our understanding of the poem, but why it's mapping onto our understanding of the poem is another question that we need to follow up with. So maybe it's first person, but I don't think we've done the investigation yet.
We can measure
but
that,
first,
though, right?
But first person affects the suffixes, not the prefixes. So if you put first person everywhere, you get the same statistics in principle. So mathematically, I don't see the link yet. Empirically, there may be one. We do have like a signal. So I recall you saying that, Elton, again. So it's definitely something we should dive into and see the statistics for first person versus the rest, for example. This is something like a test we could do.
But can we see, I mean, we can see that, right? We can see which trigrams.
Yeah. It's an excellent question, and I think it's
we can try and see whether it's the suffixes or anything else. We can actually check that out.
I think that this has also brought up by Chiara, I mean, suffixes and prefixes, Chiara and Ryan. But so far, we haven't found any strong bias driving this. I mean, we tested a few, not all, exhaustively. But first person versus third versus rest, I think it's something we haven't exhaustively searched so far.
Chiara, did you want to add?
Yeah, no, it sounds intuitively satisfying to me that that morphology might have something to do with it. If you have a model trained with it on a lot of third person singular, so as it transitions character-wise from the stem to the ending, it's used to seeing some morphology, and then suddenly it sees a different morphology, it's going to have a harder time guessing the first person morphology because it has seen fewer examples of it. So intuitively, that's how I interpret some of that data, at least. But yeah, definitely we should test it more.
Chiara, could I put this question to Ryan? Ryan, what's your take on that? On the intuition?
Yeah, I mean, my interpretation is fundamentally the same one. I mean, essentially, you're going to have n-gram sequences, trigram or 4-gram character sequences, which will in part or whole contain pronouns or inflectional endings for the first person. So something like first person singular nominative egal. That's going to occur more often, I would expect, in books 9 through 12 of the Odyssey than in almost any other chunk of Homer. So, and that could be precisely a character trigram. And regardless of exactly what size of n-grams we set, then we're going to find n-grams where those pieces of morphology or pronouns, I would think, would be higher, but this is easy to find out empirically. We can find out exactly what the frequencies of particular n-gram sequences that we expect to find in pieces of inflectional morphology and pronouns for the first person, and see if those indeed are more frequent in books 9 through 12 than in other parts, and see exactly what the correlation there is to the corresponding perplexity scores. So this is easy to investigate empirically.
And I think
definitely,
that gives us an opportunity before we go to Chiara and Ryan's work to answer, or to give John a chance to answer Stephen's question about perplexity. Stephen, do you want to rephrase your perplexity question one more time?
Gladly.
Please.
What is perplexity and the way that you're using it? I don't really
All right.
know.
So just adding a quick follow-up on the previous topic, seeing whether first person or otherwise tokens affect perplexity is the question. And when we see that in synthetic data or some tests, then we could apply it empirically. So we could see whether first, if I change the endings, how much does it affect, and if it affects it. I mean, intuitively, it may make sense to some of us, but we can show it. So we can count it. So this is an interesting direction, just putting a pause there. On the perplexity is, in effect, if you take how probably is the next character after the next sequence. So we have like a sequence, and then we have a model that measured statistics. And then you present a first person gram, first person token, and another one. So you have one probability for the one and one probability for the other. So we know that, but one thing occurs in the sequence, one of the two. It's either first person or not. So if you go like a time series, one after the other, what happened, you measured based on the model, the probabilities. So you sum the logarithms of the probabilities. So it's like the average information you got from the things you've seen based on what you knew on your model. This is perplexity in intuitively mathematical terms. But if we put it in simple terms, it's really the surprise you got from that sequence based on your education.
Wonderful. Thanks so much. Do we have time to open it up to questions from the crowd, or do we need to move on?
So yeah, I think we should move on. We have general questions at the end. Again, thank you, Stephen. And I've spent some time bean counting as well, but not nearly as well as you have. John, Maria, Elton, thank you for the inspiration. And then just to go to our other partners, Chiara, Bozzone, Ryan, Sandell, will present some of their work, and then they'll have a response from Justin Arft. I hope that Stephen and everybody will stay around for questions after all the presentations for a more broad conversation. So Chiara, Ryan, the stage is yours, and I'll try to spotlight you correctly.
Perfect.
Thanks.
Good afternoon, everybody. It's a pleasure to be here. So the goal of this talk is to give an overview of the work that Sandell and I have done using quantitative authorship analysis, which is a set of statistical techniques and machine learning methods that can be used to study textual authorship. And we did this in order to shed light on the Homeric question. Now, in this collaboration, clearly, I play the Homerist and classical philologist, and Ryan is the data scientist. I will walk you through this presentation today, but Ryan is here and available to answer all of your technical questions. But let's get started. So our goal in 2022 was essentially to answer a very basic question. Can we use quantitative methods to replicate some of the main conclusions concerning the Homeric question that scholars have converged upon using qualitative methods? And we know that there are many aspects of the Homeric questions that are still highly debated, but in general, I would say that nowadays, a lot of scholars would agree with the following statements: that the Iliad and the Odyssey were likely composed or textualized at least by two different authors, that the Iliad was composed prior to the Odyssey, and that the poems were not immune from interpolations or expansions, and Iliad 10, the Lunea, has long been suspected of being a secondary edition of some kind, starting actually from antiquity. So can we replicate some of these results using quantitative methods? In this paper, we did two studies. The first trying to answer the question, is a single Homer that is the same author for Iliad and Odyssey together likely? And for study number two, what can we say about the internal structure of the epics, so of the Iliad and the Odyssey respectively? For technical details and code, you can look at Ryan's GitHub page. Now I wanted to give you a quick overview of the basics of quantitative authorship analysis. So QAA, as it is practiced today, as its roots in the middle of the 20th century, one celebrated early and successful application was a paper by Mosteller and Wallace on the Federalist Papers. And what Mosteller and Wallace did was to develop some valuable guidelines for assessing authorships that we still follow today. For instance, topical lexical items should be excluded because you don't want to group two documents together just because they talk about the same things. And instead, the frequencies of function words, that is very high frequency items, are a good diagnostic of authorships. Essentially, you want to look at linguistic features that are so tiny and so unconscious that even the best imitators could not accurately replicate them. There are many different types of authorship attribution problems. We're not going to go through all of them, but what I wanted to point out to you today is that the problem that we have with Homer is the hardest one of all, because we are not trying to establish whether the Iliad or the Odyssey can be attributed to an author that we already know, and we don't even know how many authors we're really looking for. So for this reason, there is not one 100% guaranteed method that will yield an answer. What we are presenting today is kind of a reasonable attempt at attacking the problem. So essentially, to conduct a QAA study, you have to follow 3 steps. You have to establish and clean your corpus. We used TLG digital editions. We stripped them all of punctuation, converted them to lowercase, and saved as plain text files, 1 text file for each traditional book division. Then you have to choose and gather your features. For these studies, we looked at character trigrams, so sequences of 3 characters, and word bigrams, so sequences of 2 words. Then step 3 is to assess the similarity of your documents and then to visualize the results. And we did this usually mostly dendrograms, so little trees. We're going to see some examples. So here are the top 100 most frequent word bigrams in Homer after we clean them. And what I wanted to point out here is that these features are really quite innocent. They are by and large sequences of function words. And even the few features that have content words are really generic, like apameibomenos, teroenta proseuda. We actually removed all personal names and place names, and we also manually removed any further potentially contentful features like epithets that can be more strongly associated with one epic or one hero than another. These are the top 500 most frequent character trigrams in Homer, and we did not clean these manually because the procedure that uses the top 500 trigrams does not require manual cleaning. Again, most of these are just little bits and pieces of words or 2 words next to each other that are really not meaningful by themselves. They're not contentful. Now, for each document, the next step is to measure the frequency of each feature under study. Then you assess how similar all documents are to each other based on those frequency measures, and this is calculated as distance. And then based on these distance measures, you then ask a clustering algorithm to group documents together. The idea here is that basically the same author will tend to unconsciously use the same features at similar rates. Now, there are many different settings that you can choose for both how to calculate your distance measures and for how you want your clustering algorithm to work. So there's not just one identical answer, but you can actually ask the question multiple times and have multiple answers. These are the procedures for our two studies at a glance. For study one, we had our feature set, then we fed it into a distance matrix, and then we did hierarchical clustering with average linkage. In study two, there's one more step, which is we used a co-association matrix using k-means clustering. This is an extra processing. And we did this because we wanted to get a clearer signal. In study number two, we were trying to get some more fine-grained answers as to the internal structure of the Iliad and the Odyssey. And so we felt it would be useful to add this extra step. Once you have your clusters, you visualize them. We visualize them as dendrograms. And this, when you see a dendrogram like this, you have to read it from the bottom up. So if you try to read this dendrogram here, essentially what this means is that documents E and F were the closest, and so they were grouped, clustered together first. Then A and B were the closest remaining, and they were grouped together. Then the average of E and F was closest to D. This is why it's called average linkage. Was the next closest, so it was grouped together. Then the average of D, E, F was closest to C. And finally, the two nodes, A, B, and C, D, E, F were joined at the root. Okay, so let's now go to our first study where we try to ask, is a single Homer likely? Essentially, we asked, can our tools identify a clear Homeric authorial signal to the exclusion of other Greek authors that we know, for instance, Apollonius Rhodius or Herodotus? So here we had both hexametric authors and non-hexametric authors. Essentially, are all works of Homer consistently grouped under a single common root node? So the corpus we put together for this contains both hexametric poetry and a few historians. There's a large number of documents. And the features that we used are the top 53 word bigrams. And these are the 53 most frequent bigrams that occur in at least 50% of the documents. And this is what they look like. Again, as you can see, there's really not much content-wise in here. And this is the result. So I'm going to zoom in, don't worry. But essentially, we can see a top node split between older hexametric poetry, which is kind of here at the bottom. We have nonnos in the middle, and at the top, we have the historians. And now we're going to zoom on the historians. Now, there is a single node here dominating each distinct known author. So an authorial signal using this method seems to be identifiable for Herodotus, Thucydides, and for Xenophon. There is one interesting wrinkle here. Books 1 and 2 of the Hellenica, as you can see, are shown to share a common ancestor with Thucydides. Now, this is good news because this is a known authorship problem, and it is widely believed that the first two books of the Hellenica might be based on an original source material from Thucydides. So our model seems to have detected something of that. Now, in the middle, we can see nonnos, essentially just minding his own business. So essentially for the historians and for nonnos, we get clear authorial signals. What do we get for archaic epic? Essentially a total mess. So here we see that for Apollonius Rhodius, there is a single node, which indicates authorship, so that's a good sign, but it is grouped together with some books of the Iliad. If we look lower, there's a node with much of the Odyssey, but then we have other books of the Odyssey that are mixed together with books of the Iliad, works of Hesiod, and even some of the longer Homeric hymns that we threw in. Essentially, there is no single node dominating all books of the Iliad and the Odyssey. Their last common ancestor includes the Argonautica, Hesiod, and the Homeric hymns. And even the Odyssey has no last common ancestor that excludes Hesiod or the Homeric hymns. And we can also add that, interestingly, works and days and theogony are also not clustered together. So it's kind of a mess. So in general, we can see that at least using this method for archaic epic, there is no clear authorial signal. Now we're going to go to our second study where we looked at the internal groupings in the Homeric corpus. And I'm only going to give you like a tiny taster here. But so first we looked at the Iliad and the Odyssey taken together. And our main question was, can we replicate the general consensus? And the answer seems to be yes. So essentially, we can see here that the Iliad and the Odyssey are clearly split in two nice groups. And moreover, Iliad 10 up here is isolated within the Iliad. We see this in the height of the clusters too. Height corresponds to the distance between the two clusters. So Iliad 10 was really the last one added to the group of the Iliad. There's also a few promising internal structures, and we really don't have time to linger on right now, but the first person books of the Odyssey are also here on their own to the side. Well, in the previous slide, we saw clean Iliad versus Odyssey split. I also want to stress that these methods can also find similarities between the two epics. Here, for instance, the distance between our books is visualized in a two-dimensional space using principal component analysis. Now, Iliad books are in red and Odyssey books are in green. 2 points I wanted to make here. We can confirm how isolated Iliad 10 is. It's like way up there. We can also see that some books of the Iliad are sort of on the border with the Odyssey, and these are pretty much the ones that you would expect, namely 1, 24, 9, and 23, which contain some later looking linguistic features. This was already observed by Munro. So this looks good. I do not know what is going on with Odyssey 12. One thing that I should point out, so also Odyssey 12 looks slightly isolated. It is still close to Odyssey 10, while Iliad 10 is really like way out there in space by itself. But yeah, this is something worth investigating. And yeah, I have a few more trees and stuff like that, but I think this is a good point to move to our general conclusion. So what do these first results tell us? So can we replicate the consensus using quantitative methods? I think yes, at least in part we can. Is a single Homer, author of the Iliad and the Odyssey, together likely? Based on what we've seen, not really. I don't think so. Study 2, what can be said about the internal structure of the Iliad and the Odyssey taken by themselves? Again, we've seen that Iliad 10 is a clear outlier. There's also some thematic groups that emerge. So there are clear cases in which we see groupings that seem to reflect some thematic factors, but okay, but this is without any thematic words in it, just based on the frequency of pi and something else. Based on study 1 and 2 together, I would say that this to me looks like more like a multiple event model of textualization is more likely than, you know, a single author sitting down at some point and textualizing the whole Iliad or the whole Odyssey. Looking forward, I would like to test our methods on other oral formulaic texts where we actually know the authorship, because the question is, did study 1 struggle with hexametric poetry because of the technique of composition? And of course, the ideal candidate for this would be the Montpellier collection of oral literature. Like that, we could maybe try to see which features and which settings are best at telling different known singers apart, if at all. Though these texts are available in either print editions or online, they aren't available in a machine-readable form yet. So the first step there would be to OCR a selection of them or all of them, representative samples, and then do it. So that's something we'd like to do. Another thing that I would really like to look at is beyond using word diagrams and character trigrams, I would also like to look at metrical features, line shapes, metrical faults, all sorts of potential metrical features. This is another aspect of a poet's language that is made up of largely automatic and unconscious behaviors. And we also know that these behaviors, these preferences changed over time. So I think it would be really interesting to see if the data from the bigrams and the trigrams lines up in some way in the metrical data. And of course, how this data all compares with the vast existing analytic tradition. And this is where we're gonna leave you. Thank you.
Thank you, Chiara. I'm going to bring Justin into the mix. I don't know if do you want to leave the presentation up, or do you want to drop it while he speaks? And so, Justin, do you have a presentation?
I'll drop it.
I mean,
Okay.
I have some things I could show, but based on everything I've heard today, I could just as easily not use any of that and just ask a lot of questions.
Okay, well, how do you want to do it? It's your time now, Justin.
Yeah, so I guess yeah, I can pull up something if I need to, but I just want to say, like, so the two let's see, everybody can hear me all right? I just got a warning about unmuting. Okay, got it. I've been staring at, I guess it's figure 7 that you showed from that from your article, and I've been looking at that heat map from John and Maria's work a lot lately. And actually, if I will share my screen, and just so you can all see what I'm referring to here. I've been staring at this a lot lately. And I'm particularly, I'm coming at this from somebody who studies Homer from an oral poetic standpoint, and one of the reasons I'm so drawn to the concept of traditional referentiality is because it tries to make meaning out of correlations, right? Out of things that are patterned, right? And so in a lot of cases, I guess we could call, like formulae that appear everywhere in the epics. I mean, I don't want to reduce it to this, but we call that noise. And I'm looking for signal. Usually I'm looking for things that are interformular, things that happen in a specific and limited set of contexts, and then ask this question, okay, well, why are these 3 formulae in the Odyssey appearing in these exact 3 places in the Iliad, and can that tell us anything about the relationship between these 6 different places that these 6 different formulae appear? And that's just kind of my general approach. That's how I've always qualitatively thought about the epic. So when I see this massive quantitative evidence, I am blown away. I mean, some of it confirms some of the things that I've always thought, but some of it is perplexing, I guess we could say. So what I am really wondering, what I started to think about is I really wanted to know what was going on right there in that little cluster. Because if the bigrams and if these character sequences are telling us that there is some kind of similarity there, again, zooming out on a thematic and generic and qualitative level, I've spent a lot of time this last month or so just like trying to come up with qualitative similarities between these particular books of the Iliad and the Odyssey. And what it has kind of resulted in is a mess for me. I've produced so many notes, and I feel like the guy in the picture who's drawing the lines between all the things in the conspiracy map. And so it's been a fun challenge, but one of the things that I was initially kind of surprised by this, and my immediate questions are, beyond the characters, beyond the bigrams, beyond these small units of correlation, is there stylistic or compositional similarity between all of these, right? And I think that's something we've kind of flagged today, is that in future work, we need some amount of annotation or coding beyond the level of just what the raw data is telling us, and then also, as my next question is, are there lexical correspondences between these? And I just picked this one little cluster. Are there lexical correspondences between all these books? And so I'm not playing this presentation because sometimes the Mac makes things go haywire. So I'm just ham-handedly going through these slides. But so my initial approach was, as someone who is not a data scientist and does not understand a lot of these techniques as well as you all do. I just started to do a TLG n-gram search and changing the settings. And anyone who's used that knows that it's, you know, you really have to commit to it, and you can't really search things. You have to just click through the entire sequence. But I started looking at kind of, you know, 3 and 4 word chunks just to see if I could find any specific and limited correspondences, things that were only in those particular books of the Iliad and the Odyssey and not anywhere else. And of course, you know, it generated quite a few formulae that we would expect to see anywhere in the epics. But I was looking for things that only appeared in those books, and the results were not many. I couldn't find a lot of them, you know, and that honestly kind of surprised me a little bit, because you know, if there's a lot of correspondence at the level of bigram, then I'm interested in what is around those bigrams, right? And Chiara, I think what you're saying about the next step being looking for the metrical characteristics of all of these chunks. And I've been thinking a lot about your 2022 piece in the Rethinking Orality volume on chunking as well. And so I feel like that would be a next step for me, is to start to analyze, you know, the metrical shapes of these units to see if there's any, if it increases the level of correspondence. But just to show you kind of a homerist in the wild reacting to some of these findings. Well, one example of a formula that the TLG picked up on in a lemma search. So it's looking for different, you know, it's not looking for exact textual similarity, but it's actually looking at different cases within the formula. This is one that it picked out, and it said that it was quote unquote only in these 2 places. And one in Iliad 9, when Agamemnon is despondent and thinking about, you know, leaving the war, and he cites among the reasons he should leave is that, you know, that Zeus has devised this evil deceit, and he commands me to reach Argus with bad Kleos, since he, you know, destroyed a great army or many people. And then among those 5 books, or I'm sorry, within the entire epic, and again, I keep saying according to the TLG, because there's actually more instances of this, right? But this is just what the machine was telling me, right? In Odyssey 9, we get another instance of that when Odysseus, of course, is hedging with Polyphemus and not answering the question of who he actually is, and he's saying, "Oh yeah, I'm actually one of the people who fought for Agamemnon's army, you know, and he sacked a great city and destroyed many people." And so you know, you can rack your brain and think, okay, are there any contextual similarities here? Are there thematic similarities? Is there a reason that Iliad 9 is trying to call upon Odyssey 9 and vice versa? And you know, you can come up with any number of reasons for that, but if you look outside of just the exact kind of computer generated correspondence, and I was kind of surprised it didn't pick up on this, just to jump ahead, you know, just one example is that this particular formula reminded me of this instance in Odyssey 7, which is in a catalog. It's in a mini catalog describing the genealogy of the Phaeacian queen Arete. And it uses similar phraseology, not exact. It refers to destroying Eurymedon, who destroyed his people and himself. And this taps into a much larger set of terminology and themes and language within the epic that calls upon who and what heroes are. It's used later of Odysseus to criticize him in book 24 and like the consequences of his heroic actions. So all in all, I think what this led me to, and the questions that I have, and some of this I raised earlier, is that, you know, when we find dissimilarity between similarity, or especially dissimilarity or outliers, I think I take that as kind of a personal challenge to find similarities in the things that seem statistically to be an outlier, you know. And I think to do that, you'd have to look at the thematic level, at stylistics, and especially one of the things that's becoming apparent to me just today is I think that, you know, when we use the word author, I wonder if we can substitute genre for author. And when a genre gives constraints, does the text then immediately start to cohere to a different kind of, not traditional expectation, not hexametrical expectation, but a generic expectation that would necessarily funnel the language into a completely different kind of expression, even though it would definitely still be traditional, right? So that's a huge question that I have that I wonder if you all could address. And then also, you know, and Chiara, I think you just ended on this note, is like, how easy would it be to start looking for clausal or caesura divisions or metrics to find correspondences, you know, not between characters, but just metrical shapes. So that's a lot. I just threw that out there, but I'll let you respond to that in any way you see fit, even if that includes, you know, saying that your initial premise is completely wrong. You're not thinking about this the right way at all.
No, so thank you so much for all these questions, and
yeah, thanks, Justin.
hopefully I can remember.
Yeah.
But
Do you want to say something, Chiara, or?
I will also let you speak later.
Okay. Okay, thanks.
I mean, what I wanted to say is that, of course, quantitative method, especially this quantitative authorship analysis that we're doing, is looking at a fraction of the evidence that a philologist would be looking at. And in particular, like that image that that you brought up. Oh, I need to share my screen.
Yeah, I can bring it up if that would be helpful.
No, I need to show something else.
Okay.
Sorry. Okay, let me share my screen. Then I will. Okay, sorry, 1 second. So the fact that those books appeared close together was based entirely on how frequently these 100-word diagrams appeared in those books. So there's, you know, you're thinking of the genre, the style. The genre might dictate if some of these sequences appear or not. Probably yes, if you're in a catalog, you're not going to have a lot of dialogue going on. So there's an argument maybe to be made that we should get rid even of the ones that indicate speech, for instance. But what this method is trying to get at is some features of, let's say, an individual author's grammar that are so tiny and unconscious that nobody would ever notice that they're doing it. And when you do this with modern authors, this tend to point to individual authorship, regardless of genre. It tends to just point to kind of an individual footprint, fingerprint, when it comes just to how your brain produces language. My hope would be that meter has the potential to work similarly. The way you put your lines together, you know, there's definitely some unconscious processes and preferences that go in there. They can also change over time. You know, there's famous differences between the Hellenistic hexameter and earlier hexameter, but there must be some, my intuition is that there must be some individual preferences. So that's where we're trying to get at with the quantitative authorship analysis, really unconscious, tiny things. If you look at bigger models, like the ones that we discussed, I mean, that John and the others discussed, those are models that take everything in. So they can also have all those effects of genre and topic and all sorts of other things. Ryan, what did you want to add?
Yeah, I think you basically covered the main point that I wanted to make, is that in the methods of quantitative authorship analysis is that when this is done with cases where we know the answers to the question effectively, that there are no effects of genre effectively. So for instance, if we take an author who is known to write in multiple different genres, then focusing on things like the frequencies of function words or frequencies of character sequences, which will tend to, in a language, especially a language with more inflectional morphology than English, for instance, tend to pick up on the preferences in using certain types of inflectional morphology, for instance. And these are, precisely as Chiara said, unconscious aspects of the grammar of a speaker, which can only be picked up effectively in a quantitative analysis, and precisely excluding anything that is contentful, or trying to exclude things that are contentful as much as possible. That's going to eliminate in an analysis like this any sort of thing that looks like intertextuality, because that will tend to precisely be more contentful, but those contentful things will give the appearance of similarity where we don't actually want to find similarity, because that doesn't tell us anything necessarily about the aspects of the speaker's grammars, the things that they're doing unconsciously.
Right. Yeah. And what I wonder immediately is, like, if you look at those top 100 and the top 53 bigrams, if you could determine the metrical shapes of those, because a lot of those, if we're thinking of like nuclear and peripheral elements in a formulaic system, those things seem to, those drive the composition. Those are probably the first thing the poet or singer thinks of, and then everything else falls into place.
Bits of glue.
Metrical in the line, right? And so, is it possible that the bigrams are secondary to the compositional process, and if you could isolate their metrical shapes, and that's what I meant when I said it would be interesting to see, because they do indicate something, but what are they? Do they indicate like, are they better indicators of what is around the bigrams, right? Is like what the core elements are, and would there be? And I would imagine that if you where there are similarities between those bigrams and in particularly their metrical quantities, I bet there would be a correspondence of types of vocabulary or types of phrases around them.
Yeah, I would guess that to be the case.
The meaningful, and so then you could run a search of some kind to determine if there is some kind of similarity between, types of verbs, types of adjectives, types of phrases being used.
We have a couple of questions from attendees. I've promoted one to a panelist so he can show his face and ask his question if you'd like. Richard Martin, would you like to ask your question?
Hi there. Thanks for the promotion. I don't get promoted anymore, so this is the only time I get promoted. And thank you, Chiara, for a wonderfully lucid presentation and exciting, and it opens all kinds of questions. So I had one observation and one question. And the observation, it fits with your very welcome finding or intuition that this is not a one-time Big Bang textualization process, but maybe multiple sites over multiple eras. I can't help but think of the sociology behind this. That one of the few things we do know is the rhapsodic blenderizer, if I can call it that, where the same guys and maybe women had in their heads Homer, Hesiod, Homeric hymns, cyclic, all of that mess, the word that keeps coming up. So it's not surprising at all that you find this kind of dirtier situation within an agonistic context, using a formulaic tradition where the stakes are how to push the envelope and reuse formulae. So, that I share Justin's hesitation about authorship as being an important factor. Which brings me to the question, and I'm going to defer, of course, to two brilliant dissertation students who are right here, Annie and Stephen, when it comes to the data. But I'm just thinking in terms of those bigrams, the word bigrams, when you look at them, and you've already pointed towards this, the higher node is clearly what kind of discourse strategies the poets are using. And do they want to represent speech exchange? But others in that list, and I took a little screenshot of it for myself, are clearly related to type scenes. And I think of speech exchange as a type scene too. So what you're really seeing, I suspect, is the choice of particular poets in particular moments to prioritize particular type scenes, whether they're speech or otherwise. And that will take you through almost all of those bigrams, I think. So that's the observation / question. Could that be what's happening? Thank you.
Thank you so much. Yeah, no, I think definitely there can still be content factors that we haven't been able to completely scrub, at least from the 100 bigrams, and maybe anything indicating speech needs to go. If what we're trying to get is this really unconscious sort of fingerprint of a given possible individual poet. I know that this is maybe a fool's errand, but the first step in this study was trying to see if these tools that work nowadays to find individual authors would work on something like this. And I also do think that there must be an effect when you have authors that are all, when you have singers who are all operating within a much stricter set of rules, then the effect must be homogenizing to an extent. I believe there must still be some amount left of individual preferences one way or another, and ideally maybe our methods can still find it. But I think there is going to be a homogenizing effect, which is maybe what we see in study 1, where basically everything that is hexametrical and it's not nonus gets just thrown together and it's just jumbled together. This is why I think it would be very valuable to test whether these methods work on other oral formulaic traditions where we actually know the answers.
And I think your point about multi-stage textualization event is one I found really exciting and sort of cohering, Richard, in part with Greg's evolutionary model. David, you wanted to ask a question. We do after this question and answer, we'll go to the next presentation. But David, since you are here, I wanted to get you in on it too.
Hi, I'm enjoying this so much. Thanks for the amazing presentation. I just wanted to jump in kind of on this last exchange between you and Richard and your final remarks there. I guess as speaking from the point of view of someone who's worked with the Millman-Perry materials, and I would like to say that I certainly hope that that somebody will figure out a way to digitize and make those all machine readable and so on in the not too distant future. I keep pushing my institution to cough up the $1.25 million or $2 million it would take to digitize all those recordings, and they to date have not bitten on that. But I guess I wanted also to inject a slight note of caution. So if I could start from the idea that what we were talking about, homogenization or the rhapsodic blenderizing effect in Richard's memorable phrase, we could start from the notion that kind of homogenization is somehow a proxy for social cohesion, for the relationships between performers who belong to this tradition. And then I would like to point out that at the time that Perry is making his collection in the Kingdom of Yugoslavia, it's really a time of disintegration of the tradition. It's following the collapse of much of the social structures that the Ottoman world had brought to the region, much of the social structures that supported the development of the heroic tradition in its sort of most elaborate flowering. So I just want to say that there's a long established view that the Perry materials are the best comparand that we have for understanding Homeric composition, but I have come over time to be more and more skeptical of that, or at least I've come to the view that the apparent proximity, when you look at a range of contemporary attested oral traditions, also obscures very important dissimilarities. So I would expect there to be a much higher degree of dissimilarity, not just between individual singers and the Perry corpus, by the way, but also between, if you were to look at texts that were recorded on discs and texts that were taken down by dictation. Albert Lord himself already noted that there were important differences in word choice, in formula structure in those two cases. And then my last point, and I'm sorry for going on at such length, but my last point is that it seems to me a big unknown concerns the process of Homeric textualization itself, and the fact that we don't really know how much intervention there is, even post-transcription, let's put it that way, how much intervention there is in the text. So how capable would the kind of analysis that you've presented here, how capable would that be of disaggregating, kind of those later interventions in the text? So just a few comments and remarks, but also I want to say that this is really inspiring work to think about how we can apply these methods to this kind of analysis. So thank you.
Thank you so much. Yes, your first 2 points are extremely valuable. And yeah. As for the third point, I think, and what I'm latching on is this idea, if the textualization has been so long and complex as many of us like to believe, like, is there any hope of that these methods are going to yield anything meaningful? Well, at least maybe we can use them to prove that what other people think, which is early fixation and very, very little change, and, a single authorial presence very strongly, controlling most of the choices, maybe that doesn't really seem to match what our methods find. So maybe, I'm not going to be able to tell you that on March 20th, Homer, was looking out on the plain of Troy and started singing from book 3, but I might be able to tell you that, look, if it were one guy or 3 guys sitting down together after a festival and textualizing it in one go, we would expect to find something else, and we don't find it. So maybe kind of a more minimalist approach.
And I still think there's hope, David and Richard, to think again from a multi-textual perspective. One of the challenges we talked about in our conversations earlier was the data set going in, and it's coming from the TLG, right? It's Allen's text for the Iliad, right? And so, in von der Meulen, if we perhaps putting into the model multiple texts, the variants, the apparatus might show us not like a really early text, but might show some more of the joins and show us where some of the lines and fissures are that can allow us to think through these problems more. And so that's one of the data scraping or pre-processing problems to talk about. And so again, I'm so excited people are jumping in, but I don't want to push us too far past the 4 o'clock. So we do want to go to the other presentations. So part of what we're doing now is setting the table for future conversations, and we're taking some good notes on it. So next, we're going to move to Annie Lamar, who's going to talk about applying some of these things in the classroom with a response by Suzanne Lai. So thank you everyone so far. And Annie, I'm going to highlight you, and you have a presentation to add to.
I do. Is my microphone working okay?
You're sounding great.
Fantastic. Sorry about that. The Journal of Open Source Software, JOSS, is very well respected. It's completely peer reviewed and open source, and they allow you to publish short papers that describe monumental works of software development for different disciplines. And it's a way of getting that amount of work and labor acknowledged in the CV line that counts as an academic publication with a DOI in a well-respected journal. So even though it kind of seems like a big Band-Aid over the problem, it is solving the problem in a way. The Journal of Open Humanities Data offers the chance for people to draft data papers, where if you spend months and months creating, for example, a Homeric multi-text corpus, you can publish a data paper describing it and the labor that went into it and all of the details and the ethical guidelines you followed. And it allows you to, again, get the right kind of CV credit for the work of creating and curating data sets. And there's a growing number of journals like this that are made by people who are high up in the field and recognize that this is a problem, that we want to value these tools and developments and software and data creation. And we need to find a way for those to be valued in the current system if changing the system on its whole is not an option.
Thank you, Annie and Suzanne, for this conversation. And I just want to add before we go to the last presentation that there are methods that people who are more senior in the field and in leadership can pursue to help support this. So the first question you guys were talking about, the problem with the sciences model of being attached to a single lab and sort of a life or death situation. There are models that we have. So for instance, at Brandeis in the biochemistry program, where you come in and you do rotations through labs and you figure out which ones fit best and you sort of practice there. And so imagine a PhD model where you did rotations through different disciplines and trainings as part of it. It's almost sort of a checklist of different competencies. And then the other side, one of the things that I handle in faculty affairs is that we have many faculty coming through the ranks who are doing collaborative work, public-facing work, who are doing work in fields where their type of approach to traditional fields isn't reflected in traditional journals. And so you have to have a conscious process from the beginning. You have to hire people to particular positions. You have to say what the standards and criteria are for tenure and promotion all along, and you have to enforce it with departments and within disciplines. And so it really has to be thoughtful all the way through, but there are ways. Now, for those of us who are in this room who have late night obligations because you're far ahead in time, I understand if you can't hang out. I'm gonna shift to the final presentation today. Johannes Hubble, Jacob Murrell, and Barbara Graziosi can't be with us, and I'll add 10 minutes to the penalty clock for conversation afterwards, and then try to shut it off after that. So thank you again, Annie. I loved hearing your work. Thank you, Suzanne, and I'll now spotlight Johannes and Jacob and get us going to the last talk of the day.
Yeah, thank you very much, Joel. Can you all hear me? Yeah. All right. Good. Look, it's great to be with you. We are bringing up the rear, Jake and I, which makes sense because we came to the workshop late, and thank you for fitting us in, Joel. It's been terrific. I've learned a lot. But it's also appropriate, I think, in the sense that the Logion project is only just beginning to move in the direction of working on Homer and Hesiod. And so a lot of what we'll be saying is aspirational, really, prospective. So we are coming from a project that some of you may be familiar with. This is the Princeton-based Logion project. PI is Barbara, who cannot be with us, ironically, because she's fundraising for the project. So that rather speaks to Annie's paper just there. What is this project about? Well, it's an NLP tool, essentially, that aids the restoration and elucidation of pre-modern Greek texts. What does that mean in practice? It means philology, hard philology, if you like. We fill gaps in texts. We try to restore texts, amend texts, and we also have a line on manuscript evaluation and attribution. A lot of this has already been published, at least some of it. So here you have some of the titles. Logion works with word piece tokens. We're also experimenting with other forms of tokenization, combination of character level and word piece. It's a BERT model at the moment, so we are thinking of moving to Electra. It's trained on all the Greek that we could get our hands on, then fine-tuned on specific authors. Our proof of concept was the Byzantine polymath Michael Psellos. Why? Because a lot of his work is digitized, 1 million words roughly. That makes for a decent corpus. There is a lot of low-hanging fruit. There's a lot to be done on the text of Psellos. Plus, Maria Pantelia very kindly and generously gave us the Psellos files from in the TLG. Yeah, just to give you a sense of the kind of thing we've been doing, gap filling. Many of the letters of Michael Psellos survive on only one manuscript, typically in Oriental paper, so very friable. Bits flake off, bits get also get smudged, and so you get gaps in the text. Here in Epistle 5:17, he talks about 2 roads in life. Beautiful passage. There being 2 roads in life, one worse, one something. I have now embarked on the better one because of you, he tells his addressee. Now, no prizes for guessing roughly what needs to go in the gaps. Something like Kai Beltionos. That was our initial guess. But of course, the machine suggested te Kai Beltionos and insisted, even after we sort of tried to very hard to persuade it to get rid of the te. Well, we thought te Kai Beltionos is too long. It turns out that it's exactly right. If you look at the manuscript in question, this is the gap that's being filled. Then you will see that the ending in Beltionos is abbreviated, and that Kai takes up the space of 1 letter roughly, not 3. So te Kai Beltionos fits the space. It's also stylistically better because Psellos favors it after ditos, favors te Kai, the more compact formulation rather than simple Kai. So this is the kind of thing that Logion can do by way of filling gaps. I should emphasize, and this has been pointed out, of course, before today, that anything the machine spits out has to be vetted very carefully by human philologists. Logion does not produce philological results, much less does it make philological arguments. All this has to be done by human scholars working with the machine. So this, by way of giving an example of gap filling, then our main emphasis more recently has been on error detection and emendation, and our algorithm for that is the chance confidence ratio, so-called, devised by Charlie Cohen-Breen, then at Princeton, now at MIT. He had this very simple but really rather compelling intuition that what we need to do really in order to spot problematic passages in a text is not simply to tell the machine to flag the least probable words in their current context, because what it then comes up with is hapax legomena, names, things that are rare but perfectly acceptable. A much better approach is to introduce a ratio of unlikelihood that a word in its present context is correct, and then high likelihood that it can be replaced with a better word. And this is the chance confidence ratio, which we have been applying with some success. Now, mostly we put a Levenstein distance 1 filter over this. Levenstein distance 2 can give some decent results. Levenstein distance 3, it already begins to get quite shaky. A quick example of the kind of thing that the machine will pick up in one of Psellos's poems, 17 in Westering's edition, and this is the recent Teubner. This is the best edition we have. The word puzzling form filate appears several times in the printed edition, and in the TLG there is even a little note that there's a Byzantine form of filitate, which is the expected form. Well, Logion insists that we do want to cut it into pattern. If you look at the of course, they do spell so here we are proofs against which we can check what the machine is doing. All right, so that just by way of a warm-up. And now I'm going to hand over to Jake. So for the sort of more technical side of things and for talking about our move towards hexameter poetry, Homer and Hesiod. I guess I should stop sharing so that you can share your PowerPoint, Jake, is that?
It should be the same one, shouldn't it? Yeah.
Okay, so I can click you through, yeah?
Yeah. It was here,
Okay.
yeah. So the text we've done, so I was recently hired as the research software engineer to help on the project. And the stuff we've done is, well, they did Cellus and philological emendations for Aristotle's metaphysics. And more recently, we've done Pseudo-Heronianus. And so with all these, with the positive results we saw with all these different prose texts, the interest was how to apply Logion's suggestions to verse. And we were chiefly interested in Hesiod's catalog of women. But the question becomes, there were several challenges that verse posed. One, the issue of formulaic text, in that our current process, we deduplicate many repeated text strings. And because we don't want them to negatively affect the model or create a linguistic bias. And so the issue of these formulaic passages that appear in epic verse, but then also the issue of meter, because when making the suggestions, it has to make sure that whatever suggestion it makes is metrically sound. You see this all the time. And when they fill in text or they create a artificial Homer, the text is not hexameter, right? And so we decided to, before going to Hesiod, we decided to experiment with Homer, or the plan is now to experiment with Homer, preparing the experiments to do that. One, because the multitude of fixed and flexible formula in Homer compared to Hesiod. Two, that Homer's what's extant of Homer is more complete than Hesiod. And three, it's the canonical status, right? Homer's the Hamlet of ancient Greek. There's no dearth of scholarship on Homer. So, but yeah, so the duplicate text, and here is an example of one issue with the fixed and flexible formula, is the model would have to be able to recognize the changes between these two passages as not erroneous. It would have to be able to predict. So currently the thing I'm exploring is just rudimentary NLP experiments with n-grams to see how the different, and deduplication to see how the formula affect the model's predictions, and if it can accurately predict variations in formula. And the other issue was meter. When you have lacuna, as often happens with the catalog of women, spanning several metrical feet, the model has to consider how many metrical feet it's proposing. And so this was actually the bigger problem. The formula is sort of lower, just low-hanging fruit. The meters, and there are many different questions. At the current, we fine-tune models, just traditional model fine-tuning. So we pre-train on our large corpus. I think the current one's about 90 million word tokens of ancient Greek, but we're expanding it. And so we just do traditional fine-tuning. So we pre-train the model, and then we fine-tune it to Cellus or Aristotle, and then we test it on one part of that text to produce the philological suggestions. The question was with meter, would the pre-training, if it's not fine-tuning to meter, how do we fine-tune to meter? And so one question was a sort of retrieval model, such as retrieval augmentation. If you have it retrieve only when making its philological suggestions, if it focuses on other metrical texts, such as Homer or other Hesiod texts. And the other thing was Macronizer. I'm talking with, wish they could have been here. I didn't think of it. Talking with a researcher at Lund who's creating a Macronizer for ancient Greek. And the idea would be to annotate the metrical feet, and the model would learn. So it would learn these annotations for long vowels and whatnot. So yeah, and then the last issue is, but this is more very easily solved, is restoration. Is that currently we use, as Johannes mentioned, a BERT model to make suggestions for specific words. But if we're doing these longer form gap restoration, it would require a decoder model such as Llama or GPT. So, yeah.
Okay, thank you, Jake. And just to give you a first taste of what we are after, what we are ultimately hoping to have a go at, this is a typical fragment from the Hesiotic Catalog of Women. It's of course the Epikunstsprache, not very far from Homeric Greek, but it's fragmentary. In this case, half lines are missing from the beginning. One approach to this, an obvious approach, would be to try to fill the gaps, get Logion to make suggestions for gap filling. But of course, one can turn this round. One can take existing attempts to fill the gaps and run error detection on those. So I suspect this is not a good infill here. So interesting to see. We haven't had time to run this yet, but this is something that's in the making. And it'll be interesting to see what the machine makes of that. Similarly, in fragment 150, Matterbach West 99 most, there are some gaps that are filled in a way that I think is unconvincing. Herr Feisters is almost certainly wrong here. Old restoration by Lupa, I don't know why most revived it. I haven't had a chance to ask him. But so this is the kind of thing where we are hoping Logion will ultimately make an impact. Okay, thank you.
If you can stop sharing, we can bring more people in to talk about this, because I think moving, what we've done in the process of this workshop is we've gone from analyzing text and using models to think about what we have to now we're at the point where we are taking zombie texts and reviving them in a way. And that is really that's an amazing potential, but it fills me with fear and worry. So I'd like to hear, maybe from the data scientists or our homerists, what do you think of the future of Logion, and what are your hopes for the resurrection of Hesiod's catalog of women? I don't know who has any thoughts and wants to jump in and our sort of last 10 minutes together. All right, Justin, I see you first. I thought it was either going to be you or Elton. I didn't know who was going to come in first.
Yeah, thank you both for this. I mean, that sounds really exciting. But I have questions, obviously. But yeah, fragment 204 would be my personal request. If you're taking requests, but it is a contested one. But I immediately wonder, and I'm sure you've thought about this, and I'm sure there are enormous limitations, but how does the corpus of verse inscriptions fit into this? Or do you have your eye on that? Or, I mean, that's a very difficult corpus to work with, but I don't know if that's something you would have to isolate and work on by itself, or if you would be able to add some hexameters from that corpus to create a little variability when you're reconstructing things.
Yes, so we have one collaborator in Pisa who is working on a verse description in the Doric dialect, Doric hexameter. For that, I think it would still help to train on the hexameter corpus, obviously. But the other way around, I think, is sort of fiddly to add hexameter inscriptions to our training corpus, and wouldn't, I suspect, make that much of a positive impact, just simply because, I haven't looked into this very carefully, but my sense would be that you wouldn't add huge amounts of usable data. So yeah, that would be my initial initial reply. Of course, in all of this, we have to remember always that what an algorithm like Logion can do is make diagnostic conjectures, no more. And then it is for human philologists really to do the work. I mean, I'm now with Miriam Kotwick. We are preparing something on Logion and Aristotle, and of course that's you can imagine that's really tricky. I mean, Aristotle, the text of Aristotle is not like that of Psellos. It's well groomed. It's well catered. It's not so easy to make real inroads. And Logion, with its essentially lectio facilio approach to things, right? What is more likely floats to the top, but that's highly problematic in philological terms. I mean, we do well to mistrust the lectio facilio. So that there was a real question whether Logion would be able to do anything useful with Aristotle. But it to our surprise, I think it's fair to say, it has the most useful, I think, things it has done is point us to alternative manuscript readings. So where the transmission is split, or where perhaps there is an indirect witness, like Alexander of Aphrodisias in his commentary, giving a reading of which Logion, of course, knows nothing. If the machine then plumbs for that reading, that is usually a good reason to think about it very hard. It doesn't mean, that in itself is not an argument that we should adopt it, but it can prompt further investigation. And then yeah.
Well, so I was going to jump on what Justin said to send in any other questions, and Elton's still thinking, to encourage like opening up the database just a little. I know the difference might be small, but if you think about the PHI database of inscriptions, one of my concerns is the homogenization that has happened over time during the process of the creation of textual editions, right? From the Hellenistic period through the Byzantine period to, let's use the example, whether or not we really want to, of M.L. West's Odyssey, right? Like if you took just his version of the Odyssey and used that to train your LLM on, or then you would get a very different thing than if you included it. And when I read through the metrical inscriptions in PHI, especially the funerary epigrams, what I sense is a continuity of oral performance and skill that's going in between text and orality. And so there may be some things like the variants of what I'm interested in, Johannes, where the textual tradition has said, no, this is too weird, right? And it's been relegated to the critical apparatus. And then that doesn't end up in our databases that we're searching. And so then when we talk about the lectio facilior, it's leaving out all those things that editors over time have agreed don't belong there.
Those are really good points, Joel. Well taken. Yes. I guess, I mean, the main problem here is people power. Not manpower is not what we say. But it's simple resource.
Yeah.
We are completely overwhelmed with this stuff, and we are now. I mean, one idea we have is to try and use Logion improvements or Logion inspired improvements to the text of Psellos to make a new text that we can then publish. So outside, the paywall of the TLG, and potentially, that could lead on to other texts being published in this way. But it's slow work, it's painstaking, and we lack the resource. So yes, in principle, you are right. Those are good points, and ideally we would really want to go through the inscriptions and filter out what is usable. I mean, obviously, if one just throws everything in, you get noise, you get yeah. But yeah, thank you.
I just laugh at. I know I was chuckling not at you, but you said in principle I'm right, and then I thought, but in practical terms you're useless. And it just felt like something my spouse might say to me during a particular discussion. No. But
no, Joel, this is just me having a moment of weakness because
I hear. Because this is the great challenge of our digital editions, right? Is that we
Yes.
still don't have an interface that allows them to have multiple dimensions, right? And if we think about the technology of the critical apparatus, it's still a better technology, even though it can lie as well, than what we have with the TLG presentation.
Much better, yeah.
Sorry, I'm taking up too much time. Other questions? Does anybody else want to hassle Johannes?
Well, I mean, you have kind of prompted me to say something, so I
Sorry,
feel as though I
Elton.
would. But my angle is going to be rather quite different, and it relates to the talk we heard just before, which is about collaboration, and I think also what Johannes you were saying there about the difficulty that you're finding. You're doing a lot of stuff here, actually, and so I'm kind of wondering, you go from Aristotle to the to Hesiod and these other texts. And you also mentioned epigraphy, and then there's John in the room here, and so my mind turns to the DeepMind Ithaca project and how they were using that to, a kind of similar idea actually of looking for gaps in text and trying to come up with a way of giving some responses that scholars can at least think with. And I'm curious about the different models that are being used here and whether actually there are opportunities for really interesting collaboration to help both projects. I mean, this is also an invitation then, I guess, to John if he wanted to say anything about that. But I mean, this was the first thing I thought of when you were talking, Johannes. And by the way, it looks great. I can't wait to kind of explore further.
Yeah, well, look, thank you very much, Elton. Lovely to see you. And discuss these things. Ithaca in particular is plagued by serious problems. I mean, we all know that. We are working on a review actually for it because some of these things need spelling out. There is serious overfitting in the way that Ithaca was trained. So it has this very small data set, but was run on huge compute, and one of our students looked into this actually for their senior thesis, and he found really grave problems of overfitting, which also explains why Ithaca is useless outside its very limited remit of these inscriptions. Yes, but there are things to learn. Absolutely, there are things to learn from Ithaca. For example, the way they combine different types of tokens that we've got from them, and yes, we are very keen to collaborate. That sounds very vague and so global, but I mean, we have a group of smart philologists in Pisa, for example, who are helping us alleviate the problems at the philological end. But yeah.
So I think John, since you had the first word today, I'll give you the last, and then we'll close.
Thanks. Well, I'm just picking up where Elton left me to. Thank you for the nice presentation, Johannes. Very nice. I can't help remind, before Ithaca, all masked language models. It really reminds me of how masked language models work. So we talked about language modeling, like the next word, but what BERT and other masked language models do is hide a word and guess it from the context. And I think this is based on this paradigm, which is very, very interesting, where I'm kind of skeptic, not of this approach, but also mine approach, but also maybe Chiara's and Ryan approach is, where is the baseline? I think there was a question in the panel somewhere, maybe Suzanne, but the idea is, I recall a method of imposters, they call it. It was an authorship attribution. So in order to verify whether it was an author or not, they had many from the genre, but it's contemporary. And they tried to find the one that was not an imposter. But this is easy. When we go back in ancient languages and we go that back and we can't have any imposters, how do we create data sets to control how the models work? So in other words, I mean, if you hide a content word and if you hide a stop word and if you hide formulaic or anything else, you have different performance. How do we do this sensitivity testing, assess everything so that we know?
John, just to make sure I understand you correctly, is this a question about ground truth?
No, not really. It's a measure of, I mean, does this method work equally on all possible datasets, on all possible authors? My
Right.
question is,
Yeah. Well, that is, yes. Thank you for clarifying. That is indeed the million-dollar question. And I mean, we have approached it pragmatically. We are sort of moving from, one type of text to another. A large corpus which has not been very well edited in Psellos, which is relatively uniform. I mean, Psellos writes beautifully Attic Greek. He's a stickler for grammatical precision. He talks about it all the time. And so this is in a way the perfect opening gambit and all this. Then you move on to a text which is edited differently, which works differently linguistically. Aristotle. Then you move on from prose to poetry. But it's all sort of very much make it up as you go. It's not very thought out. I mean, I don't know if you have a better, a good sense of how this might be done.
Maybe not. I mean, I have the same issue, so it's a criticism to myself basically. But thinking of this, I'm having two suggestions to myself, to my future self. So one is try to break the system. So can we make a data set that is uniform, and then if we apply the clustering or the language modeling or the master language modeling, then it suggests something that it shouldn't. So can we stress test it on the other way? So try to make this random baseline and show that the model doesn't work or says, no, I can't respond. That's one. And the other is we do have LLMs, but maybe we should not be using them to work as systems, but maybe they could synthesize data. So maybe we could create like synthetic data. So that's a thought I'm having here. Haven't thought about it, just thinking out loud, haven't thought about it thoroughly, but just leaving it to the room.
Yeah, interesting. Thank you very much. Thank you. I mean, we've been sort of having thoughts, I think, in a similar direction. Data augmentation. We compile annotations, runs of annotations that are then fed back into the training. But thank you. This is all baby steps as far as we are concerned, certainly.
So I want to thank everyone for showing up today, sharing the work and sharing the conversation. For people who are interested in continuing the conversation, we don't know what we're doing next. We'd like to do more workshops, maybe do some stuff in person. We're going to write some of this up, share some of the questions online, and keep going. For those of you who are interested, Elton, Maria, John, and I get together every other week or so and just have a conversation about what we're doing. Chiara and Ryan have joined us recently. And we just keep sort of thinking and talking about things. Shoot me an email. I'll tell you when the next hangout is, and we'll see what happens next. I hope people collaborate and think about this and just walk around with counterfeit homers in their head. Everybody have a great day. Have a safe month of November. I hope it's a happy one for all of us. Everyone, take care.
Thank you so much, Joe.
Thanks,
Bye,
Joe.
everyone.
Thanks,
Bye, all.
everybody.
Thank you,
Take care.
everyone.